but Adrian will take over from next week. So today you should have, those of you, 2 of you enrolled in the class, should have your assignments handed in. I've left it open till midnight tonight, so you've got a bit of time. So, do you have any questions about the assignment at all? Or?
Did you want that photo board, the cartoon strip, uploaded as well, or handed in paper? Scan it and upload
it's
it?
not a photo board. It's oh, you mean the storyboard? Oh yeah. What would be good to do would be to scan it on this, and Katie can show you how to use our scanner, and then you can upload the scanned image. That would be great.
Cool.
Yeah, it's pretty simple. So we've got another assignment due today, due next week, which is a prototyping assignment. So I'll pass those out to the 2 of you. I'll give Adrian one as well. So basically, this last lecture, we talked about how to do sketching and more sketching and prototyping. And this assignment is supposed to do a design task. Let me just look at that for a second. So the idea is that we have out in the core here, we have the HitLab photo board. And what we'd like you to do is to try and think of a way to show information on the photo board in a more interactive way. So right now we've just got still photographs of people. And so you should think about how you could add some interactive technology to make it more interesting and interactive. And in particular, there should be 3 things you should show. You know, who are the people in the lab, and the information about each person, such as their background or their degree they're enrolled in or role in the lab. Secondly, what projects are being worked on in the lab and who's actively working on the projects. And third, if a person is physically present in the lab. So you can imagine there's some magic technology that knows when you're here or not. Maybe there's a seat sensor, and when you sit on your seat and it assumes you're here, then you have to show that on the photo board as well. So what the deliverables due are a sketch of the interface, a storyboard showing interaction with the system, and most importantly, a video mock-up showing the system in use. And so let me show you some examples of what the students did last semester, and you get an idea about the video mock-up. And to make the video mock-up, you could use several tools. So some students last semester did it by using PowerPoint and just did kind of a time-lapse PowerPoint and then did a screen grab and saved it to video. There's a free tool for, free for 2 weeks tool for the Mac called OmniGraph, which allows you to do sketching design really easily. You could use Flash, or you could use some still video edit. Like last week, the last lecture, I showed you an example of the mind map application for the iPad, which was made up by basically still images strung together. So let me show you an example of what some students did from last semester, and you can see. So this is one of them, and what this person did is made a, there we go. So this person made a PowerPoint animated slide. So you can see nothing. Excellent. It'll just take a second to start up, I think. There we go. So here's the photo board, and then they have an animation of a hand coming across, showing how you can click on different people, and then when you click on the people, you've got information about the person, and there's a projects tab. You can click on that, and then it tells you about different projects. Click on the project, and it will tell you more about the project and who the people are working on the project. The people are color-coded, so if they're red, they're not in the lab. If they're green, they're in the lab. And then you can also sign in by putting your own code in there, and that changes excuse me, the color code of your face. So that's one person's effort at doing that, and then that was done with PowerPoint. Then let me show you another one that was done through OmniGraph, which I think is this one here. Yeah, so if I push this across to here, this is, in this case they wanted to use mobile augmented reality, so they had this, so OmniGraph is a layout tool that lets you, so they basically made stop motions with that, so they you came up to the photo board with your phone, and then on the phone you'd see this little application running, and then you could touch things on the application, and it would search by I guess people's presence. So when you touch that, it sorts them all and puts the people in the lab at the top, and then you could tap a photograph to get information about a person, and then there's information, and there's different options for information. You could bio there. Video, and so you can click on the tab and it shows a video of the person, and then you can return to the photo board, and that's about it. So let me just escape. Oops, is my mouse gone? Oh, there we go. Great. So is that clear as far as things go? If you are lost as far as making a small video goes, you can talk to Timo. He'll give you lots of help. Because he knows how to make videos really well. Or the other person in the lab is Tham. Tham's a pro video editor, which is really good. So last time we talked about this tension between elaboration and reduction. So the idea is that at the beginning of the design process, you want to try and develop as many designs as possible. And then as you go through the design process, you start doing more decision making, and you reduce the designs down to the ones you're actually going to be developing. And then we also talked about this notion of a design funnel, where you have concept generation at the beginning, and then you funnel down through the different concepts until you finally get the final concept you're doing. So at each point you have some new ideas being generated off the previous ideas. So you generate a whole bunch of concepts here. A lot of them will be bad, so you whittle out the bad ones, and then based on the good ones, you expand that further. It's more reduction. You keep on doing that over and over again until you get to the final concept. And as you do this, the granularity of the interface goes from very broad to very refined, and the communication or prototype you're developing becomes more refined as well. So we also talked about different prototyping tools as well. So we started with sketching, and that's a really great tool because it's very fluid, and it's a great way to communicate ideas with very low overhead. And I showed you some examples of these are kind of hybrid sketches where you take a photograph and you can sketch in by tracing somebody into that picture, or a little storyboard of how you might use it. So we showed and talked a little bit last week about what the good things about sketching are. What might be some of the disadvantages of sketching? Does anybody have any thoughts about that?
It's very sort of static, or depending how detailed you go, but it's very static. It doesn't show any dynamic.
Right. So with the paper sketch, there's obviously no interactivity. And the storyboards try and show what might happen, but it's still not the same as being able to push at an object. Is there any other disadvantages with sketches you can think of?
Can be quite fictitious.
Fictitious?
Yeah, so it's like it's all made up.
Right, so there's some magic technology there that you may never be able to make real. Yeah, it's no disadvantage. But I think the one you first mentioned about how it's not interactive is one of the main disadvantages. But it's such a powerful tool that people use it anyway. And then we talked about the notion of going from sketching through to full prototypes. And the investment and effort increases over time, and you start focusing more on the usability as opposed to the design, which is in the sketching phase. So when we went through a number of different prototyping tools, so we started talking about sketching and paper prototyping, and a subset of that was video prototyping. I showed the example last week of that. Then wireframe and schematics, and using HTML, and then more interactive prototypes. So I just want to review some of those and just talk a little bit more about the pros and cons. So here's paper prototyping. In this case, you've got the person put some tracing paper here, so they try to get around the limitation of sketching by adding some kind of paper-based interactivity. So you can hit the submit button, and when you hit the submit button, it's going to then put up a new screen showing what it is. So the great thing about that is that it's very quick and dirty, and doesn't require any software, and everybody can sketch. The disadvantage is sometimes it's not quick enough. Sometimes it takes time to make sketches. the sketches can be too rough, so too dirty. It can be hard to share because now you've got a paper sketch, now you've got to digitize in some ways. And you still need some way to document and explain further what the sketch is talking about. So the next step on from sketching is working at wireframes and doing page schematics. So here's a wireframe or a page schematic for a website, some sort of Liverpool to do or something. I'm not sure. Anyway, so there's a whole bunch of, and so what they've done is they've developed a schematic for the page, and then they've have these call-outs from each part of the page explaining what it does. So this is combining the documentation with the interface together.
Just one question.
Yeah.
You said that sketching is kind of easy to do. So what do you think about all this kind of sketching software, which is you see a lot of them? How much they are really effective, or how people find them?
Well, it depends on what the goal is. So, for prototyping, the goal is basically to be able to communicate with the least amount of work as possible, especially in the brainstorming phase. So, for doing that, you may just be able to draw a very crude box and a couple of buttons and say, well, this is my new iPhone interface, and this is what it's going to do. In that case, maybe the software wouldn't be working. But when you start getting to the point where you're trying to communicate back to the client, you might want to use more professional software like you've got as well. There's always an overhead with using software, so if it takes you a long time to learn how to use the sketching software, you may want to go straight to a tool like OmniGraph or a more professional layout tool. Yeah. But the one advantage, I guess, of course, is once you use sketching software, it digitizes right away as well. So that's a bonus. And of course, if you have a tablet or an iPad or an Android device that you can draw on, then it becomes very intuitive to sketch as well. So, yeah. So with wireframes, they're very good for defining content and documenting screens. They can be bad at showing interactivity, although I showed you an example from Wednesday with the Palm where they showed the flow through there. You can't really use them for testing because they're not interactive, and they can be slow to develop because it takes a long time to describe everything that's happening on the page. So some people then go and do HTML-based wireframes. So here's a prototype for the Inland Revenue website, and you'll see on the left-hand side here is their HTML wireframe prototype. What that basically means is they just cut and pasted a bunch of HTML to make functionality work, but it looks pretty ugly. And then on the right-hand side, they've now spruced it up and added some more graphic elements to make it more pretty. But the left-hand side is more like a prototype. So and the main focus of doing an HTML prototype is that you can then edit the interactivity, so you can push the buttons and have things working. So so now we can. The positive of that is that you can show interactivity and flow. It's very good for simple interaction. It can be experienced in the browser, so you can share it remotely with people. The bad thing about this is that sometimes you need HTML knowledge, although I gave you an example last week of Podoko, and Podoko generates the HTML site for you automatically to prototype. You can spend a lot of time in the HTML hacking the layout. You can only show what you can build, and sometimes people get locked into designs, and which means that they don't throw them away. Well, really, that they should do. This is all just showing interactivity, and they shouldn't get locked into. You can see here, for example, they've put on the right-hand side things like calculator, contact us, and then that has flown through onto the right-hand side of here. And it may or may not be a good idea to put that there, but once you do the HTML, then sometimes customers and clients start locking into your initial design ideas. What you really want to do is describe what users are going to do with your interface, and so that's done by visualizing the user experience. So you want to be able to show the steps to complete a task, not complete a talk, to show every click, and to use screen flows. So this is where a tool like Flash comes in to play. So here's two different screens for a accounting software, and they want to show what happens when you fill out a new invoice or start filling a new invoice. So in this case, they use Flash as a design tool, and they can use Flash to animate between the two screens and show the flow. So, hey Rory, so the most important thing is to focus on the flow between the screens and to communicate what happens at different points in time. And so things like Flash or screen flow technology is ideal for explaining changes over time. It can again be experienced in the browser, and it reduces the need for documentation. And that's really because when you're developing user experience, it's really the transition between the states which defines the experience. It's not, and we talked about this way back in the first lecture. We talked about how interface interaction design isn't just about saying what happens on the screen or in a device at a particular point in time. It's a communication with the user, with the technology over time. So it's really the transitions. So Bill Buxton, who's a very famous HCI pioneer, he says that unless you can show me where you've fleshed out the character and aspects of transitions at the same level of thought, rationale, exploration, and fidelity as you have the states, then you're fired. So he basically said it's not good enough to produce pretty screens. You have to show how to go between the screens and how to interact with technology. One of the ways to do that is by using design patterns. And so there are some well-defined design ideas or design patterns that show how to go between different screen states. So for example, Yahoo, on their website, and they have a developer network, they've produced a bunch of different design patterns that are quite commonly used, in this case in web applications, but there are also design patterns for other things as well. So if you're doing a computer game, then there are some quite commonly used design patterns in computer games. But let me show this first of all, and then we can talk a little bit more. So if I go back to my, not there, I think I have a web link to the... Oh, I'm sorry, you're right, it's right there. I was used to using two screens. So here's the Yahoo design patterns. And so basically what this is a whole list of different type of, there's a whole bunch of patterns here, but here's some new ones they've just added. So here's different ways of doing different things. So for example, users, in this case, users create a collection and wants to display to other people. So here's a collection of photographs. So if you click on this link, then Yahoo provide some ideas how to do this. So here's the problem. The user's create a collection, wants to display to other people. When to use this? You can use this when creating opportunities for people to create collections of things. Users to show off their collection outside the original location of the collection. So one example might be with Flickr. So somebody has a whole bunch of collection of photographs. They want to show the photographs. So you can use this design pattern, or maybe a collection of objects, or a collection of web pages they've collected, or whatever else. So that's the problem, and this is when to use it. And here's a solution. This allow users to create modules or badges that display a portion of the collection, provide users with a URL or embed tag for the collection display, consider creating widgets to display collections on major social networks, allow the user to select a subset of items to display. Items displayed should link back to the original site. So if the item is a URL, then link the tags back to the parent. So if you had Flickr collection of photographs, then when you click on the photograph, it should link back to the original site and show the original photograph. I think there's some examples. Yeah, so here's some examples here. Flickr, Delicious, or SlideShare. So if we click through on Delicious, it will take you to the Delicious website, and it'll show you I guess I'm not a member, so I can't do that. But anyway, so that's a great example. If we go back to the Flickr, then it'll show you off the Flickr site. Then you go to, actually I guess I should go to the gallery. Well, it'll show it here. So here you can see how Flickr put out collections of photos. So anyway, so on the Yahoo page, there's a whole bunch of patterns. If we go back again, here's a design pattern about an accordion. So what happens when there are too many items to fit into a limited space that overwhelming the user? If you click through this, then it'll tell you. So here's a whole bunch of sports messages, and they're all accordioned up. But when you mouse over this one, it expands out and provides more information on that. So here's solution. You have a top level and a second level of options, and then you have collapsible panels, and then some other options there. And there's some examples of it being used. Right, maybe this one. So here's a code how to do that in the HTML. And is that going to show it? I guess it shows the screenshot. I was looking for an animated version, but I don't see that. Anyway, that gives you an idea. So that's one example of a design pattern, and how you would you can look at other people's ideas for transitions. We talked last week about tools that can be used to build interactive prototypes, and one tool that we talked about was Podoko. There's another tool that is Azure, and Azure is similar to Podoko in that you just lay out objects on the site, and then you can publish them to a test website and test it out. There's another interesting tool called Microsoft Sketchflow. And Sketchflow is really great because what it lets you do is it lets you design a user interface, but it also lets you add logic here and provides a visual representation of the flow between interface screens. So you design a bunch of pages, and then it can be quite complicated if you've got this could be a website, or it could be screens on a PDA or on a phone application. So you might have dozens of screens. It might start getting quite complicated. So in this case, you can link them all together and add some behaviors to the screens. So you'll see a bit more here. It's quite dark, isn't it? But you've got this is the current screen. There's a blue line down to this screen, and there's another screen here. And then you can add, when you click on this tab here, it's going to go down to this screen here. If you click on something else, go to this screen. So you can add different widgets and events here as well. I've got a little video of that working, so let me show you that. Yeah, so actually, it doesn't, that's right, it doesn't play in Safari, so I have to drag it over Chrome. Go back here. And volume. And I think Microsoft, this is based on Microsoft Silverlight technology, and I think Microsoft, it used to be a paid application, but they've just rebranded it and they've called it Microsoft Brand Expression or something. And it's free now, so you just use it within Visual Studio and you can do this stuff. Let me show you a video of that working. And that's really not loud.
Create the flow of my application UI. Very quickly I can get a sense of how the user will navigate through this application.
I've got three
and at any time I can build and test the application to quickly find and fix issues with the UI flow. Controls that are sketchy in style help the client understand that this is an early stage prototype. Don't be fooled though by the sketchy style. These are real Silverlight controls. To test the project, our clients simply need to Silverlight enable the browser. Prototypes are brought to life with transitions, animation, and interactivity, and remain as conceptual or become as real as a particular project or client demands. Sketchflow also enables clients to send actionable feedback about the prototype using the built-in text drawing controls in the Sketchflow player. The client can navigate the prototype, making separate notes and annotations on each application screen. The client can then send that feedback to the development team, who can now review it in context on the design surface. Creating documentation is time-consuming. Sketchflow speeds up that process by literally turning the project into a Word document, complete with a table of contents and screenshots of all of the different screens and application states. Sketchflow is just one of the powerful new features in Expression Blend 3.
Right, so you can see that it had a number of interesting features. One was that you could lay out the user interface, you could sketch the interactions between the interface. But you could also, the client, when you send it to them, they could also add their own annotations and communicate back. And then I really like how you can automatically generate a document template in Word, and then you just got to go and fill out all the different parts there. So.
One issue which is maybe kind of it used to be the case that people get used to a kind of a software, and by the time they learn this and find it very hard to change or to move to another software.
Right.
Sometimes after people get adapted to the software, most of the companies will do little bit changes, not then to interfere with the kind of the experience and usability they have gained. But now I think with the web pages, it's become completely different issue. People will kind of go for a web page, and then in a few seconds, if they don't really kind of find like how to do things, they just kind of leave to another place, which is maybe kind of put more pressure kind of in different pattern designing application than web pages. But in the same time, now we are seeing more into what they call the web app, which is somehow in between. So I don't know how people really kind of act on these things because they are not really that intensive on computations.
Well, even if you're doing a web page or web app, they still have similar design problems. So and ideally what you try and do is isolate the user from the technology and produce a well-designed experience so they can interact with it easily regardless of the technology they have. So I think it's not really a problem, I don't think. So, yeah, but the users have to, well, users do evolve and learn over time, so it should be okay.
I think like in designing a web page and designing application require kind of different, I think, aspects. It's not the same because we use them in different ways.
Sure, yeah. Well, I guess people are expecting their applications to be more like web experiences in some ways, and that they want to have, or they want them to be always connected, and they want to have them to be able to have the same kind of visual style and everything as well. Anyway, let me go on a bit more. So that's, and then you can get this. They just announced some changes. So they said that it used to be called Sketchflow, but now it's part of Expression Blend, and you can download that and try it for yourself if you want, and see how it works. So that may be something actually you could use for your assignment if you were very brave and wanted to learn some software.
Is Expression Web just like a web version of it?
Expression Web is different. This is so unfortunately they've got a lot of name confusion, and this is a tool for developing vector. Is it Expression Design, which is a tool for developing vector graphics, and Expression Web is a way to build websites, but not focusing on the. So the Sketchflow is specifically about user interface design, and it happens to be able to export to the web and be run over the web, but it's not about designing websites. Expression Web is it's a website design tool, so it's a bit different. But there's some name confusion there, unfortunately. Okay. So. So this is both examples of interactive prototypes. They are good for testing moderately complex interactions. They have some support for collecting feedback, you can generate some specs. However, it can be difficult sometimes to do custom interaction. So if you're doing a user interface design for an in-car display for in-car navigation, then maybe Sketchflow wouldn't be the best tool to use because it's more designed for screen-based design. You may need to do some coding and development languages, although Sketchflow doesn't require that. Sometimes it's not cross-platform, and sometimes you have to think more like a developer than a designer once you start putting logic there. So here's kind of a matrix that compares different tools. So you've got video prototyping at the top, there's paper, PowerPoint. I didn't talk about Visio, but Visio is a graph layout tool, and Fireworks and Azure, these are web design and screen design tools, and HTML as well. So you can see the pros and cons with each, and what most people do is typically use different tools, different points in the design process. So at the beginning you might do some sketching, and then once you've come to that first point of narrowing down design ideas, you might then do some PowerPoint slides or something like that, and then you might turn some of those into an animation, use a tool like Sketchflow or something to make it more animated. I wanted to show you also another small video which is showing you the OmniGraph working. So this is another tool that you can potentially use for the Mac, unfortunately, only runs on the Mac, but here's OmniGraph. What OmniGraph does is it lets you create animated mock-ups, and then you can export to iMovie. So this is an example of using OmniGraph to communicate about a gyro-enabled file sharing app. So you can imagine if people have two mobile phones, maybe if I want to share an app with you, I hit my phone with your phone, and then it copies the file over. So so here's one to share a file. So this is the basic thing. So first you have to enable the net with a bump. So now they're going to show you creating the bump animation. So they're just going to do frame by frame of moving the phone around. And they're creating a whole sequence of slides here. And then when they've created the slide sequence, they'll export it out to make the movie. So you can see it's just like stop motion animations. Dragging and then bumping with the phone there. And then you can have a little kind of bump action thing happening. And you can now go to the it's bumped. Now you can you want to drag the file from one place to another. And there's a hand icon you can use for dragging. And as he's doing each of these little animations, each one is being saved out, and so he's creating a whole sequence of slides down here. It takes a bit of time, but some. Export it out all as a PNG, and then you can bring it into iMovie, and you can make exports all the slides out, and then you bring it to iMovie and put it in transitions between the slides, and you can drag and drop all the PNGs, and hey presto, in 3 minutes you've got your little prototype done. Just previewing it. It's good. And now, well, you see the animation. There you go. So, very simple way of just using OmniGraph to make a animated transition. Okay, so that's prototyping. I want to talk now for the next 20 minutes about interaction metaphors. So I showed you in the first lecture about Bill Verplank's model about how when you act in the world, then something happens, and then based on something happens, you create some mental knowledge here as well. And so a goal of interface designers is to make sure that the users have a good mental model. So the mental model of the system is basically the user's own understanding of the system, mostly drawn from their interactions with the system. So Bill Verplank has this interaction design sketch process here. He says that you start off with some idea, and then you have to basically, the goal is to produce a representation of the idea in some way, and then allow people to manipulate and interact with it in some ways. But going from idea to the physical prototype is one of the things that driving it is the underlying user interface metaphor and how it's being used. So Craig, a long time ago, defined mental models as the internal construction of some aspect of the external world, enabling predictions to be made. So the idea is that you should be able to know that when you're going to push a button on a screen, then probably this thing is going to happen. And then Don Norman became very famous in the late 80s for writing a book called The Psychology of Everyday Thing. He was a cognitive psychologist at the University of California, San Diego, and then he went to Apple, and then went to Hewlett Packard, and now he's got his own company. Have any of you read this book? Okay. You've read it, have you, Danielle? Yeah, it's a really great book. Basically, it talks about how you can apply cognitive psychology principles into designing things that make them more usable. So, designing doors so you can open them, or designing buttons so that they work well. And it's all driven by underlying conceptual models. So I can highly recommend you. Yes, it's a new version of, yeah. Okay, yeah. So the idea is that there's a design model, which is the model that the interface designer is using to build the interface, and then there's the system user interface, and then there's when the user interacts with the system, they build their own model. So what do you think happens if the design model and the user interface model doesn't match up? Does anybody have any thoughts or ideas? Right, could be chaos. So let me give you a simple example, and this is drawn from the Psychology Everyday thing. Don Norman told a story about how he went to stay in a hotel, and the hotel, he had a hotel apartment, so he had a fridge in the apartment, and the fridge had a freezer and a fresh food, so it was a two-door fridge. I guess you've also seen it at home. And then had this control system here. So it had these two dials on the inside of the fridge, A, B, C, D, E, and 7, 7, 6, 5, 4, 3, all the way down to 1. And then the goal was to set the fridge. And when he got there, the fridge freezer was, the fridge itself was too cold. So when he put food into the regular fridge section, his fruit and stuff, it was getting slightly frozen. And the freezer wasn't working properly. So he was trying to mess with these controls to get it set correctly. So look at this picture here, and you can see, and they've made it quite helpful. They've got a little table that says, if you want, the normal settings are C and 5. If you want colder fresh food, then you leave it at C and you change this to 6 or 7. If you want to make the freezer colder, you move it to D and you change this to 7 or 8. If you want to warmer fresh food, then you make it C and move it into 4 and 1. So if you think about that, how do you think you would make the fresh food section would fix his problem of freezing without changing the freezer part? Does anybody have any thoughts about that?
Set the neural dial to lower number.
Right, so you could set it to. Okay, so this is when he was messing with it, he thought this is the mental model probably. He said, well, probably what it is that you have the A, B, C, D, E is controlling the freezer temperature, and the 7, 6, 5, 4, the numbers is controlling the cooling temperature. So you can see, go back to here, that if you want the colder freezer, you make this go higher, and then if you want the food to be a bit warmer, you can change the numbers here. So he messed with the fridge for about an hour trying to get this, and it wasn't working. Because actually, this was how it worked. So you basically had a cooling unit here that was only a single cooling unit that was cooling the whole system. And then you had a kind of a lever here that would change the ratio of cooling between the freezer and the drawer below. So if you wanted the freezer to be colder, then you had to use higher letters, but you may also need to change the numbers as well, depending on the overall coldness. So it was kind of a disaster because the mental model he had which was entirely reasonable. This model here was completely different from the actual model that the system designer had. So it's really important as an interface designer to help people build good conceptual models. And people, when they start using your technology, may have preconceived models already that you may not be able to change. So, for example, I don't know how many of you have used Hewlett-Packard had a HPC11 calculator, had the Polish notation calculator for engineers. And the Polish notation calculator means that you put the operators last. So instead of going 3 plus 5, you go 3 enter, 5 enter, plus. And so when you start using one of those for the first time after you've already used a infix or regular calculator, then it can be a nightmare. Or you can think of the early Mac interface when you want to export or eject a CD. You would have to drag the CD to the trash can on your Mac interface. And in real life, we don't put things in the trash that we want to keep. We put things in the trash we want to throw away. So that's another example of how people may come to it with a preconceived model that works against your interface. So as a designer, you have to be able to communicate your mental model somehow. And obviously with a fridge, they did it in a very bad... if they had drawn this picture on the side of the underneath the two wheels, it would become very easy for designers to know how to use it, or users to know how to use it, as opposed to just leaving two wheels by themselves and having them use that. So there's a number of ways you can do. You can provide good design guidelines. So first of all, customers want a good conceptual model. One of the most important things is to make things visible, to show what functions the thing has. Secondly is to map the interface controls onto the customer's model, and then also provide feedback as you go. So underlying all this is a good metaphor design. So a metaphor is basically the transference of relation between one set of objects and another set of objects to explain how they work. And there's Lakoff and Johnson, a pair of cognitive psychologists, and they think that what we do and what we think, what we experience every day is very much a matter of metaphor, and we use it every day. So, for example, in our language and thinking, we say things like he attacked every point, the criticisms are right on target. So, argument in some ways is war. So we can think about famous design metaphors and examples from computer interfaces. So one of the classic examples is the example of the first spreadsheet software. So this is a picture of a old ledger book that people used to use hundreds of years ago. So there's two pages. One page typically is the incomings, and the other page is the outgoings. So income and expenditure, and then you just keep a running tally as you go on the page. But in the late 70s, early 80s, Dan Bricklin had the idea, and this is when the very first DOS and Apple II computer was around. He had the idea that he wanted to build an electronic accounting system. And so in that case, he designed VisiCalc. And VisiCalc was the first killer application for the Apple II. In fact, many businesses bought the Apple II computer purely so they could use VisiCalc. And he was trying to build accounting software. So what he did was that he used an analogy to the ledger sheet. So you can see, just like on the page before, you've got a couple of columns, you've got a bunch of cells there. You can put numbers in the cells, and so this is very, very easy for business owners to understand because it used the same metaphor as what was used here. But it built upon it improved upon the metaphor as well. So the advantage of using VisiCalc, of course, is that you could add formulas to the cells. So when you put your numbers in, it would automatically add up all the formulas. So it really extended what accountants and others could do. So the reason why it was so good is it was a tool that people were familiar with, but then it capitalized on their familiarity with ledger sheets, but it also got the computer to form a range of distant calculations in response to user input and gave users a huge amount of power compared to what they had before. Didn't have to manually add up all the stuff now. So another classic interface is the star interface. So this was developed at Xerox PARC, and this was a computer system that was designed for office workers, and they spent several years building, or person years, so a lot of people building up a good conceptual model. But once they had the good conceptual model, they were able to develop a user interface that made it very easy to use. So this is the user interface from the star interface. And you can see it's actually, it was the very first system that had some of the common elements that are on our desktop interface today. So they had a set of icons, but because they were trying to base it on the current office worker, they had things like in and out trays. So when your email came in, it went to here. When you went to send it, you put it into the out tray. They had a clock and a calendar that was things that were typically on your desktop as well. They had representations of other devices. So here's another terminal, here's a printer. And then they tried to design the windows to look like pieces of paper. So they let them overlap, and so they're just like pieces of paper. And of course, this is what eventually became the Mac interface, and then the Windows interface as well. So one of the so that's the benefits of a good interface metaphor. The second thing I talked about is making things visible. So this relies on what's called affordances, and I'll talk a bit more about that. But basically, what you want to do is make sure the physical properties of the object show how the object functions. And so in this way, the user should know what to do instinctively. So for example, a chair, obviously has a surface you can sit on. So you may need to provide some explanations for complex things, but simple things shouldn't need an explanation. So for example, here's a washer-dryer combination. So you can see that they look almost the same, which is a good design choice maybe for the company, but they've got doors in different positions. So this is the washer, and this is the dryer. So how do you think you'd open this washer drawer here? Does anybody have any ideas? Lift it up, okay. And how about the dryer door? You pull it down? Oh, let's see. So this is how you open the washer drawer, like you said, and this is how you open the dryer door. So you can see the problem is that the designers decided that it'll be really cool if they use essentially the same door element, and so these doors are basically the same piece of metal, and they look the same, and it does look very nice design, but unfortunately they didn't provide a visual cue that makes it natural for people to use the door. So in this case, there's a big gap there, so people naturally think, oh, I'll put my hand in the gap and lift it up. In this case, there's a gap here, so people, just like you said, will put my hand in the gap and pull it down. How do you think they could change this to address that problem?
Put the gap on the left.
Yep, they could do that. What would be another way they could? They may not want to do that because these gaps kind of line up and they look kind of cool. So what would be another way they could do that? The logo there, yep. What else would be another way?
Put a handle there.
Yeah, you could probably one of the best ways will put a big handle here, and then and actually this may actually be kind of hard to use because and you could do both. You could have a gap on this side with the handle, but because it looks like there's quite a small gap there, so I'm not quite sure if you can fit your fingers in between to open it, or if you're supposed to push it somehow. Some doors push and bounce back. But anyway, that was a kind of a very bad idea of affordance. So let's talk for about 5 minutes about affordances, then we'll stop for the day. So an affordance is basically the quality of an object allowing an object relationship with an actor. That's a lot of maybe confusing words, but it essentially means is the user using the object is typically the actor, and what you want to do is you want to have some quality that conveys what the user can do with that object. So with this one here, it's a chair, obviously. And so, with this, the chair affords sitting on it. You can also stand on the chair. You've got a flat surface there. You could also stack things on the chair, but it's really obvious how to use it. It becomes a little more difficult when you look at computer interfaces. So here's a Flickr interface. And looking at that, it's not immediately obvious for some people what this affords. There's a kind of a bar here which may afford zooming, and those of you who use Google Maps probably do that. But then, maybe you can click on the interface to add objects and things like that, but it's not immediately obvious. So, affordances has its roots in psychology. There's a very famous psychologist called J.J. Gibson. He was a perceptual psychologist, and in the late 70s, he talked about the notion of affordances. And the basic idea is that the environment itself affords action, which means that, if you have a chair, the chair is shaped in such a way that somebody can sit on it. And of course, you could have a rock, you could have any object in the environment that may afford sitting. And he was arguing that this affordance is independent of the an individual's ability to perceive the possibility. So you could imagine in an environment, you could have an invisible chair, and if I knew where the invisible chair was, I could sit on it. But if I don't know where the invisible chair is, I can't sit down. But the environment still affords sitting because there's something in the environment that can sit on it. So that was the starting point, but that can be quite confusing, and it may not be helpful for interface designers. For example, is the affordance that a chair provides for sitting, is that a property of a chair, or is it a property of the person who sits on it or perceives that he or she could sit on it? So Don Norman and Jacob Nielsen, whose picture's here, they came up with the idea that you should differentiate between actual affordances and perceived affordances. So if you had the invisible chair, certainly the chair affords sitting, but it's kind of useless because nobody can see it and they can't sit on it. And then his Don Norman's definition of affordance spread quickly, and it had widespread use in the about 2000s. But Jacob Nielsen, who worked with Don Norman, the Nielsen-Norman group, he basically said that you have to, actually more than just affordances is the notion of perceived affordances, and you have to make sure the affordances, he expanded that notion further, and talking about how perception is a contextual thing as well. So it may depend upon the user's task that they're doing at the time, or the environmental context, or their goals, or their plans, or their past experience. So it's not just what they can immediately perceive, but it's also it's a cognitive experience based upon their previous experience. So it's very important when you're designing user interfaces to think about perceived affordances and how those perceived affordances are used in context. So let's talk about perception for a little, and then we'll break. So William Gaver developed this affordance framework, and he basically said there's this 2x2 grid here. So on one axis is the possibility of performing action, and the other axis is the possibility of perceiving whether you can perform the action or not. And so what you want to do is you want to make sure your interface sits in the top right-hand corner, because this is a perceived affordance interface. You could imagine that there's hidden affordances where an action is possible but you can't perceive it. There's false affordances where you think you can see something but it can't really work. And then there's this correct rejection where you can't perform an action and the object's not showing you that you can perform an action. So let me give you a couple of examples. So this is the quadrant where you want to make sure you're designing for. And a simple example of that is, a very nice example, is the door handle. So with this door handle here, it's pretty obvious. You grab it and you turn it down. Some of you may have had the unfortunate experience of going to a bank or some other places where they've got door bars. And sometimes when you see a door bar, you're not quite sure if you're supposed to push it or pull it, because with a bar like that, it affords both things. And well, it doesn't. When you look at it perceptually, you can see that you can either push or pull it, but it may not afford it. So that gets to the second thing, is the
here with the door you have the same issue. If you are from the same door, objects from inside and outside.
Yes, that's true. So you don't need to pulling and push. Yeah. But with that door handle, you do at least know you need to turn. So you can have a false affordance, and a false affordance is where you are showing that you can perform an action, but the action may not necessarily be able to be performed. So that's what was happening with the washer dryer, is that you had the gap there, providing a perceptual hint that you can grab the door from the gap, just like you did with the dryer. But when you try and do that, it doesn't work. So an example of that would be a round doorknob. So with a round doorknob, it's not immediately obvious where you're supposed to just pull or push, or if you were supposed to turn the doorknob, because a round doorknob could afford both of them. The third example is where you've got a hidden affordance. So here you have an object that can perform an action, but you may not show the person that it can perform. I guess the washer dryer is kind of an example of that, and that the door could swing out horizontally, but you weren't showing it that way. So here's an example of that. This is a hidden doorway. So there's a door there, but it doesn't provide any perceptual cues about how to open or close the door. And then, of course, the final one is a system which you can't use because it doesn't do anything and it doesn't show you it does anything. So as an interface designer, you want to make sure that you're designing in this quadrant here. And you need to be able to use visual and physical cues to be able to do that. So I've just got a couple more slides and then we'll finish. We'll just go over a minute or so. So the idea is that affordances give a clue, showing people how to use it. So the mouse button invites pushing, a door handle affords pulling, and Don Norman used this term to discuss the design of various things. And then it's since been popularized in interaction design to show how to design interface objects. And the reason why that is that he argued that people could, you could use visual cues to show affordances. So even if you're a scroll bar on a screen is just, it's obviously not a physical scroll bar, 'cause it's just a bunch of pixels on a screen, but if you draw it to look like a physical scroll bar, then it provides a clue as how to use it. And so interfaces are virtual and don't have physical affordances like physical objects, but they do have perceived affordances, and that's one of Don Norman's main contributions. So here's an example of different objects with physical affordances. There's a teacup, shows you how to hold it, door handle, doorknob here. But then you can adopt the same design ideas and put them into a virtual desktop space. So here's a scroll bar, and the scroll bar provides a strong visual cue as to how it should be used. A trash can, and you think about trash cans in real life, you put things into them, so this tells you should be putting into them. Here's a play button that's telling you should play an object as well. And maybe a push button that's different colors and like that. So as you go forward in the course, when you start thinking about designing user interfaces, you think about what affordance cues that you're providing to the end user, and how that either reinforces or conflicts with their mental model. You want to make sure they build a good mental model. So that's all we have for today. I've made some handouts. I don't think there's quite enough for everybody. There's 6. So I'll pass this around, and those of you in the back can fight over them. There's only 3 for them. Can you pass those back? And maybe somebody can copy them to other ones. So this is a one chapter from a book that talks more about interface concepts and metaphors. So does anybody have any questions about what we talked about today?
There's one left.
Oh, there's a mistake on the assignment I just noticed when I printed it out. Is that on the assignment it talks about how at the bottom it says that each of these deliverables will be reviewed in class on August the 2nd, and of course that's not the case because that's quite a long way away from now. So what I'm hoping is that Adrian will review these in the class the first Wednesday after the assignment's due. So Wednesday the assignment's due on the 8th, so is it Wednesday the 12th, I guess? And the idea would be to play the videos and show you what you've done and have a bit of a discussion about what you did and why you think your interface design is such a great interface design. Great. Okay. Well, oh, sure.
Look at all these kind of fatal design that we see and kind of try to analyze it. Someone has tried to put study and see why this is happening. Is because people are not experienced, or people maybe think different, or people like what are the main reasons like this? Because like I assume they are putting like a lot of money in producing these products.
Mm-hmm.
They maybe kind of like have thought that this would be more convenient. So this is
Well, that's a very complicated question actually. So of course there's a lot of products that are incremental. So people have been, most web browsers, at least for the PC, kind of look the same. They have a bar at the top for the URL. They have kind of forward and back buttons and a scroll bar and things like that. And so, some of those design elements, like the scroll bar, have been adopted from previous user interfaces, like Word or whatever. Some of them have to have some element of invention. So somebody who, the Mosaic browser, that was the first web browser, had a bar at the top for putting URL to it. And so every browser after that has incrementally copied that design. So a lot of design is incremental without considering necessarily the cognitive and perceptual elements. But then, of course, in most cases, people, once they've used a web browser a few times, then they get in their mind how it should work, and then future designers know that the users have this mental model of how browsers work, and they design for that model. So they know that people expect to have a URL bar, they know they expect forward and back arrows. If you're designing a radically new product, that becomes more of a challenge, because then you're trying to introduce something into the market people have never used before, and then you try, and that's where the mental model design becomes very important. Because do you include elements from things that people might know and put in this product? Do you have a whole new product that you have to teach people how to use? So that's where, and if you're designing a whole new product, then you oftentimes have to draw on some cognitive psychology background. How big do you make the buttons? What colors do you make the buttons? How do you show people where they can put their fingers to use it and things like that? So there's a lot of thought and research that goes into that. But unfortunately, some companies aren't very good at that, and so and you've all had experience like the washer dryer, where you've had a bunch of engineers build something that is functionally very good, but the usability is very difficult because they haven't thought through the design elements. And hopefully that's what classes like this and papers like you're reading will help with, is that when you do some more design, you think more clearly not just about the underlying technology, but how to represent that to people. But there's a whole, 20 years of research on one of the big benefits, and if you've got the time, I really recommend you to read Don Norman's book, because it was a real revolution showing how that the cognitive science, there's a whole study of cognitive science. So psychologists have been studying a long time how people form mental models of the real world. And he was the first person to show that same discipline had real relevance to user interface design. And the same way we form mental models of maps in our mind when we're walking from one real world location to another real world location, some of the same ability is exactly how we form maps when we go through screens on an application, or when our ancestors were hunter-gatherers in the plains of Africa or wherever, and trying to, the perceptual skills we had there in terms of being able to distinguish colour from background are the same perceptual skills that we use when we distinguish coloured objects on a screen from the background. So there's a whole literature of perception that can come to play in interface design. Yeah, it's a really great book though, really, really good book. I highly encourage. And it's really good because he talks not about computer interfaces so much, but about everyday objects, and then draws inferences from those into how you can design computer interfaces. Anyway, I've run out of time, so thank you for attending. And Jihad's got a very interesting course now. He's going to teach about, you should go and see if you can round up your students, and I will be going I'm leaving the lab on Tuesday next week, but I'll be available by email and by Skype and stuff as well if you need me. And I'll be back at the end of June, hopefully wearing a brand new pair of Google glasses. We'll see if Google let me steal away with a pair of glasses.
In terms of the deliverable